One of the reasons why I'm using Behavior Designer Pro is because of one of the most powerful features of the package, aside from the visual editor, which is very powerful in itself. The visual editor allows us to quickly iterate over our NPC behaviors and also serves as a debugging tool to know exactly what your NPC is doing. But I'm not talking about the visual editor, I'm actually talking about Subtrees. And this is what we're going to see. Here I created a new prefab. So we have on one side a peasant, which is meant to be a soldier, and on the other side we have a worker. These two NPCs will share a lot of behaviors. Right now, the only behavior they could share is sleeping. So we're going to see how to share the sleeping behavior between them. Let's go into the peasant's behavior tree. So this whole branch, this is our sleeping behavior, where the NPC will either go to bed or sleep on the floor when their energy is depleted. Let's see how we can take this whole tree and share it between a lot of NPCs without having to just copy-paste this. We can indeed copy these tasks and paste them into the behavior tree of another NPC. But doing so means that any change you make on this sleeping branch, you're going to have to redo for each NPC prefab. So instead, we're going to store this branch in a subtree. So let's go to our folder. Here I have my tiny village folder, and in it I have content and scripts. I'm going to go into content, then I'm going to create a subfolder here. I'm going to call it behavior trees, and in here I'm going to right click, then create, then observe behavior designer subtree, and let's call our subtree sleep. And here I can click on this open button and I can open it like the behavior trees on our characters. So I can create something. Let's create a sequence. Let's go to composites, sequence. Let's just add an idle task just to test this. Okay, let's close this. So this object, which is a scriptable object, contains a behavior tree, and we can use this subtree in the behavior trees of our characters. Let's go to the peasant and let's open it. In order to use that subtree, we need to create a subtree reference node. So let's hit space, actions, and down here we have subtree reference. In the inspector, I can add our subtree here. If I click on this circle, I can choose my subtree here. Let's put it right here and let's connect it to the start. Let's right click, then connect to start. So our behavior tree component will ignore our actual tree and will just execute this one. So I'm going to run the game and you're going to see that the subtree reference is being replaced by the actual behavior tree inside of the scriptable object. All right. So as you can see upon execution, our subtree has been used here. Let's exit play mode. When exiting play mode, you can see that we have our subtree reference back. Since subtrees are scriptable objects, they live at the project level, so they can't exactly access elements on our game objects or in the scene, but we can give them some variables to work with. Let's go to our sleep subtree, and here let's create a variable. Let's call it sleep duration, and let's add it. Let's choose float. Let's set it by default to 10. Now back to our character. Let's open the behavior tree of the character. When going into the inspector of the subtree reference, we can see that we can override the value of sleep duration here. So we can choose a value to override, or we can give it the value of one of our variables. So let's click on this dot, and here we can choose our float variables. So let's say, for example, I give it energy. When I run this behavior tree, now the value of energy will be passed to the subtree, and the subtree will be able to use that. And you can do the same for game objects and all sorts of other variables. So this is very powerful, and that's not the only way to use subtrees. We can in fact replace the whole behavior tree with a subtree. In the behavior tree component, we have a subtree field. If we choose a subtree here, let's say our sleep subtree, then the whole behavior tree is replaced by this. So now when I open the behavior tree, all I can see is my sleep behavior tree. So here it says editing subtree. So indeed you can have multiple game objects that are different from each other, and let's say different prefabs, and they can all share the same subtrees if you use them like this. So I'm going to click on this subtree, then hit delete. Now I'm back to the behavior tree that has been stored in this component. Perhaps you need to delete the variables of the subtree in order to bring your variables back. We also have another node. It's the subtree reference selector, and this is also a powerful node. So here you can add multiple subtrees, and using this index you can switch between them even at runtime. If you go to the Upsafe's YouTube channel, they have a great video on using a subtree reference selector where they have a boxer who switches between two branches of the tree. You have the boxing training and the actual boxing combat, and the character uses a subtree for each and they switch between them at runtime. So this is also a great example. Okay, let's delete all of this. And now let's work on putting all of this into a subtree. First, let's start by making it easy on ourselves. We're going to remove these variables as much as possible. Okay, let's go to our script. What we can do is actually have the sleep effects, the go into bed effects. Let's have them on our pawn script instead. So let's right click on our pawn script, edit script. In the properties, let's create a new header here. Let's call it effects. And let's have two references here for our effects. Sleep effects and go into bed effects, which are both game objects. Actually, let's create a region just to organize our code. Let's call it effects. And here we're going to have both the variables and a few methods that we can use inside of Behavior Designer. Let's create a setSleepEffectsActive method that takes a boolean. This method will call setActive on our sleep effects. We're using a question mark at the end of the variable name just in case it's null. So this is like saying if sleep effects is different than null, then do this. Let's do the same for the go into bed effects. Let's create a setGoIntoBedEffectsActive method, which we'll call setActive on our game object. Let's also go down here in the releaseBed method. Here, let's only clear the owner of the bed if current bed is different than null. And why I'm doing this is because we're going to combine the branch where we sleep on the floor and where we sleep in a bed. And here, if the character doesn't have a bed, we don't want this code to trigger an error. Okay, now let's go back to our behavior tree. So we can either work here and then from time to time apply the overrides to the prefab, or we can go into prefab mode. So we can click here to open the prefab, then go into prefab mode. That way every change we make will be reflected to the prefab. So here we need to set the sleep effects and go into bed effects. I'm just going to click here and assign them to the script. So let's assign sleep effects, and I'm going to click on emoji yawn to highlight it in the hierarchy. And then I'm going to assign it to the script. So emoji yawn, let's drag and drop it to the script. Okay. Now let's go into the behavior tree. Okay. So this sleep sequence looks very similar to the sleep on floor sequence. The only difference is this release bed action, which is a call to our release bed method. And now you understand why I modified the code to work even if we don't have a bed. Indeed, if we copy this sequence and use it here, we will get the same results. So in fact, we are repeating ourselves here. So what we're going to do is I'm going to delete this. Then I'm going to put this right here and reconnect it to the selector. So now we have this branch for sleeping, and this branch is going to bed. So let's change the name to something more accurate. Let's call it going to bed. So this branch may fail if we don't have a free bed. And in fact, we always want it to fail. So if we have a bed, we will go to the bed and this sequence will succeed, which will make our selector stop. We don't want that. We want it to fail. And if we don't have a bed, it will fail by default. So this needs to always fail. So let's hit space and go to decorators, and let's create a return failure decorator. So no matter what this sequence does, it needs to always fail. Now let's go into these actions. So actually, I don't need this to be a separate action. We can just add it here. So at the end of the actions, in the stacked action, I can add a release bed action. And in fact, in the last videos, I'm always setting this target, but it's perfectly fine to keep it empty, and the action will automatically set the target to the component on our game object. So no need to assign a reference to our pawn component. And this is especially important in case we're using subtrees, because our subtree will not have access to any component. So it makes sense to keep this empty. Okay, now let's click on this action and let's delete it. We don't need it anymore. And now let's go over these actions. So here we're setting the animator's sleep variable to false. We can just delete the reference to the animator since it can be resolved automatically. For restore energy, let's do the same thing. We don't need this anymore. And here for deactivating the sleep effects, we can add our method to do that. Let's click on the plus button and let's type set sleep effects active. And here is our method. So let's select it. And let's put it right here. And now we can delete this set active action. All the targets here will be auto-resolved to our pawn component. And for the animator, we also have an animator on the game object. So the target will be auto-resolved to that animator. Okay, let's go to this action. Here, the same thing. So for the set bool, we don't need to assign the animator. And for the set active, we'll use our method instead, set sleep effects active. And let's set it to true. And we can delete this one. Okay, we're done with the sleeping sequence. Let's go to the going to bed sequence. So these actions are fine. Here we're using a bed dynamic variable, and I removed the reference to the pawn here. Let's go to this stacked action. Here we're activating the going to bed effects. I'm going to use our method instead, set going to bed effects active, and we're going to set it to true and put it in the beginning. And now I'm going to delete the set active action. Then let's add it at the end. Set going to bed effects active, and we're going to keep it inactive, and let's delete the set active action. So we're going to bed, we're using the bed dynamic variable, and we're using our start sleeping in bed action. I'm going to delete the reference to the pawn. Okay, for this branch, we have deleted all dependencies on the variables here, so we can safely copy it to our subtree. So I'm going to select all of these nodes, then right click, copy. Then I'm going to click on my sleep subtree, and here I'm going to delete these nodes, and then right click, paste. And here they are. I'm going to delete this one and connect the selector to the start. And I'm going to go back to my peasant prefab. So you can use these drop downs to quickly move between your behavior trees. So now this is the peasant behavior tree. We're going to delete all of these nodes, then add a subtree reference here. So let's say space, subtree, here it is, subtree reference. And let's add our sleep subtree here. This is the one. So here I'm not sure that adding multiple subtrees does anything in the subtree reference node, but it definitely works for the subtree reference selector. So here we have a sleep duration, but we're going to ignore it. We're not going to use it for now. Now you can see that this is much more compact, and we can make it even more compact by collapsing this. So let's just rename this sequence to sleep in. Collapsing a branch is just something visual that you do. It doesn't change anything. This branch will be executed normally like it did before. Let's go to the variables and delete the ones that we don't need. So we don't need the sleep effects anymore. Let's remove it. We don't need going to bed effects. Let's remove it as well. We still need the energy because we're using it to interrupt the patrol sequence. And for the next patrol waypoint, we don't really need it anymore. Let's go to this action. So we're choosing a random game object from the list of patrol waypoints in the scene. If we want to store the result, we can simply use a dynamic variable. Let's call it WP, and let's go to the go to object action, and let's use our dynamic variable here. So I'm going to choose dynamic and use WP. So for the arrive distance, we set it previously to 6. Let's set it to 8. And we can also do something else. We can combine these two actions, but this should do for now. We can also have this patrolling inside a subtree. That way we'll make this behavior tree even simpler. So one other advantage of using subtrees is that you can make something basic and then later on go into your subtree and flesh out the behavior. So it's a really powerful tool to have. Here we forgot to connect this repeater to the start. Connect to start. Okay, and now let's go to the variables. Let's delete this next patrol waypoint. We're going to remove it. It's always good to go over your variables and remove the ones you don't need, so you can keep your behavior tree as simple as possible. Here, let's expand the sleeping branch. We can double click on our subtree reference to go into the subtree. Then we can use this back arrow here to go back to our previous behavior tree. So this is a cool little trick to go back and forth between your behavior trees without needing to select them in the inspector or in the project window. Okay, let's go back to our prefab. I'm going to collapse this again. And now let's test our peasants. So in the pawn manager, we spawn in 15 peasants. Our code seems to be working. We have our peasants patrolling around. So I don't like the fact that the shadows fade out at this distance. In project setting graphics, we have this PC RP asset. In here we have the shadows. So for the max distance, let's set it to 200. Okay, that was a small detail, but it's annoying to see your shadows disappear from such a small distance. Okay, so now our code is working. When the characters get tired, they will go to the beds or they sleep on the floor. We're going to see it right now. Okay, so now they start getting sleepy. These ones have slept on the floor and these ones are going to their beds. A change that we can do here is introduce walking. Our characters right now are always running. Let's have them walk while they're patrolling and only run when they're going to bed. Let's click on a peasant and go to the pawn script. So right click, edit script. So here let's add a header for locomotion. Let's add a walk speed and a run speed variables. Walk speed will be set to 1.5 and run speed will be set to 3.5, which is the current speed of the nav mesh agent. Then let's add a variable to tell us whether the character is walking or running. Let's just call it run. Then let's add a method, set run. I'm creating this specifically to use inside of Behavior Designer. We're going to set our run boolean to this argument. Let's also change the speed of our nav mesh agent depending on this run. If run is true, we'll set it to run speed, otherwise to walk speed. Let's also set the speed variable on our animator to the agent speed. And this is one fewer action that we don't have to do in Behavior Designer. Okay, let's go to our animator first. Let's double click on this locomotion blend tree. So here we have two states. We have idle and run. Let's add a third state for walking. If I click on an animation here, then the file will be highlighted in the project view. And here we have the walking animation. So let's add a third motion field here, add the motion field, and let's add our walking animation here, shield to walk. I'm going to drag and drop it here. Let's have it as the second motion. So the threshold for the walk will be exactly the walk speed, 1.5, and the threshold for running will be 3.5, and we can test it. So if speed is 0, we'll have the idle animation, and the more we go into walking, our character will walk and then we'll run. Okay, that's it for the animator. Now let's go into the behavior tree. I'm going to go into prefab mode, then open the behavior tree. When patrolling, let's call our set run. We just want to walk. So here I'm opening this stacked action and I'm going to add an action here, set run. Let's have it as the first action and we're going to keep run unchecked. Then let's expand the sleeping branch. I'm going to go into the subtree. When going to bed, we're going to run. So let's go to this stacked action and let's add our set run here. Let's have it as the first action and let's set run to checked. Okay, that's all we need. Now let's go back to the scene and let's test our code. Okay, so our characters are walking and soon their energy will be depleted. Okay, so you can see these ones are running to sleep in the beds and the other ones, of course, they don't need to run or walk because they're sleeping on their spot. After sleeping, they will walk again instead of running. So this is a nice feature to have because when we'll add other kinds of NPCs like miners or haulers, we'll need them to switch between walking and running as well. Okay, now let's start preparing a worker prefab. So I already started working on it. This is the character. Here I have an empty behavior tree. I added an animator, a nav mesh agent, and our pawn script, and also the pawn outfit randomizer. For the heads, I've chosen to give it some civilian heads. So I have these three bodies where the character wears the shirt in three different colors. Then for the left hand, I left it empty. As for the right hand, we're using a pick. We can also perhaps use a hammer and we're going to see how to switch between them. Okay, let's go into the behavior tree of this worker. And in fact, let's open it. I'm going to copy the behavior tree. Let's go to the peasant. So I'm going to copy everything, select everything using Ctrl A, then right click, copy. Then let's go back to the worker and let's paste everything. So here the worker is not going to patrol. So let's remove this. And now you can see how useful this is. We have the subtree with the whole sleeping branch. So we already have the sleeping behavior on our character. Now all we need to do is to add some idle behavior. I'm going to duplicate this repeater and connect it to the selector. Then let's add a sequence. What I want to do is just have the character look around randomly. Let's say space and type random float. Here I have the random float action. Let's connect it to the sequence. So here we can choose a random float between 0 and 360. And let's store the result in a dynamic variable. Let's call it rotate angle. And we're going to use it. Let's type rotate. Here we have the transforms method, rotate. Let's connect it to the sequence. And for the axis, we'll use 0, 1, 0. So the character rotates around the y-axis. As for the angle, we'll set our dynamic variable, rotate angle. Okay, so the character will rotate instantly, but it doesn't matter. We just want something like a placeholder behavior for now. Let's go to pawn manager and let's set the patrol count to 0. Let's just focus on this character. I also need to assign the sleep effects and go into bed effects. So here we have emoji yawn. Let's set it to go into bed effects. As for the sleep effect, we need to go into neck, head, and here we have sleep effects. Now let's apply the overrides to the prefab. Apply all. We still need to do some work here. So for the variables, we need to actually have an energy variable here, or instead we can have a custom condition. So we don't have to create a property and bind it all the time. So let's go to our scripts and tasks. Here we already have the GoToObject task. So let's create a new folder here. Let's call it conditionals. Let's create a new script. Let's call it isSleepy. So we're going to put it in the tiny village namespace. I'm just going to go into the GoToObject action and I'm going to copy these namespaces. Okay, so we need our isSleepy conditional to inherit from conditional. And for this, we need to import this namespace, so runtime.tasks.conditional. Let's override the onAwake and onUpdate methods. Here we need a reference to our pawn component. So here remember that this is not a mono behavior. So we need to actually use the variable that are provided to us by the conditional. And one of these variables is the game object. It's the object on which the behavior tree is running. So let's use GameObject.getComponent in parent of type pawn. In the onUpdate method, we'll check if pawn energy is lower than 0.1. If so, we'll return success. Otherwise, we'll return failure. Now let's go back to the Unity editor. Let's go to worker and open the behavior tree. Here in the sleeping branch, instead of doing this float comparison, which requires that we have an energy variable like we did before, let's hit space and go to actions and go to conditionals. Here, if we scroll down, we should see our isSleepy conditional. Let's use it. So if the character is sleepy, then we're going to trigger the sleep subtree. And let's just delete this. I'm going to hit delete. So I'm going to save the overrides to the prefab, apply all. Okay, so let's go to the peasant prefab and let's open the behavior tree. So here we can just remove this energy variable and let's right click, create node, conditionals, and let's add our isSleepy conditional here and let's delete the float comparison. So now that we have a custom conditional, we can in fact have this whole tree or this whole branch inside of the subtree. So that's also an option which will make your tree even more compact. So now we can go ahead and remove this energy variable. Okay, let's go out of prefab mode. Let's go back to the worker prefab. So here in the idle sequence, perhaps we should add a wait after we rotate the character. We don't want to do it every frame. Yeah, let's have it wait for 1.5 seconds. Okay, so this is our worker. As you can see, he's looking around at random angles. So the soldier has run out of energy, is going to sleep. Now we don't have a way to deplete the energy on our worker right now. So we're going to do it manually. I'm going to pause the game and I'm going to go to the energy field and set it manually to 0. And let's resume the game. And you can see that the sleeping branch on our worker has been triggered. So indeed we have shared the sleeping behavior between our worker and our soldier. And now our worker, when he wakes up, he will just keep looking around. So indeed, if we open his behavior tree, he's now in this state, in the idle state. So the behavior tree has replaced the sleeping subtree. That's why I prefer to keep it collapsed. That way we have a compact view on our behavior tree. So this is the sleeping branch and this is the idle branch. Okay, so we have successfully shared a behavior between two different NPC prefabs. Right now we have a simple sleeping behavior, but in a real game project, we may have a lot more behaviors like sleeping, eating. We can have moods like in Remold and a lot more behaviors. Next up, we'll flesh out the behavior of the worker and we'll have it carry things and work in mines, for example, and later on work as a builder even. So we're going to see a lot of behaviors that could be used in RTS games, in sandbox games and city builders, for example. So stay tuned, like this video if you like it, subscribe, share the video with a friend and on social media and all that good stuff. This really helps grow the channel. Until next time, see you later.